Good evening and welcome to Chapter 7, your last chapter for the semester. In tonight's video, we are going to try to get you to name chemical formulas. Hopefully by the end of this video, you should be able to at least attempt to name all of those compounds that you have been drawing last chapter. When I've talked about a chemical formula will show you the relative number and types of atoms in a compound. So it's going to give you those symbols and how many you have of them. So everything that you've seen or that I've put on the papers in Chapter 6, those are chemical formulas. Let's look at naming them. We're going to start with ions. So we're going to be looking at ionic compound. When we look at naming monatomic ions, it means just one ion. So we could be looking at the cation or the anion. So let's begin with the cation. The cations are, of course, the positive, and they are identified by the element's name. Let's look at the anions. The anions are going to also kind of be identified by the element name. You're still going to look up the element and look up its name, but what we're going to do is we're going to drop the ending of the name. So like the IUM or the UR or the GEN in some cases, and change it to IDE. So cations we leave the same. Anions we're going to change the ending of the name. We never usually just name an ion, but we put it together in an ionic compound. So let's look at binary ionic compounds. Binary means we just have two elements that are combining. So what we're going to do is we're going to combine the name of the cation and the name of the anion. We're always going to list the cation first, and we need to remember that the anion ending is changed to "ide." Often as we start looking up ions, we have to use what we call the stock system nomenclature. Nomenclature is just a fancy word for how we name stuff. So it is used when the cation can have more than one charge. So what you're going to do is you're going to take out that bright pink sheet that I gave you, and you're going to look at the side that has all the charges on them. And you're going to notice as you look through, some of them have a lot of different charges that the ions can take depending on what they're doing in nature, what elements they're around. So there are different charges, and we often need to know exactly which ion we use to make the compound. So if a cation can have more than one charge, we're going to use Roman numerals to indicate that charge. When we use Roman numerals, we're going to put them in parentheses immediately after the cation's name. So we still just list the cation name, and then we use parentheses to show which ion we are going to use. Now let's try to make all of that information make sense. The best way to do it is to practice with it. We look at LII. We know that the cation is listed first, the anion is second. So what I'm going to do is I'm going to look up Li. And I know that Li comes as a positive 1. And it only comes as a positive 1. So I don't have to worry about naming it any weird way because it only has one charge. When I'm writing this, I'm just going to write the name of my cation, lithium. Then I look at the anion. The anion, we don't worry about if it can have more than one charge. We don't indicate that at all, at least not yet. You'll see how that all changes next video. But for writing the name, it doesn't matter. The only thing you're going to do is change the ending. So I know that I look it up, is iodine. If I left it like that, I haven't obeyed that rule for naming my anion. So instead of iodine, I'm going to make it iodide. So I am changing the N to a D. So dropping the I and E and changing it to IDE. So I have lithium iodide. So let's look at aluminum. We look up aluminum. Aluminum can only be +3, so I don't have to do any special thing with the naming. So I just name it. So aluminum. F, again, doesn't worry about the charge, so I just have to look it up. And we know that it is fluorine. So dropping the end of fluorine, drop this, change it to IDE, and it becomes fluoride. So this compound would be aluminum fluoride. So this whole thing, we lose, make sure you're changing the ending to IDE. Next, we look up Fe. Fe is iron. Well, it can be +2 or +3. So this is where we have to get that stock system. And this is also where it gets a little confusing, because how do we know which Fe we're going to use? Well, to do this, we're going to look at the anion. So my anion is chlorine. Well, chlorine has a -1 charge. Don't worry about all those positives because we're looking at it as an anion. Anions are always negative charged. Well, if these compounds are going to basically be neutral, because there's no charge out here, we have 2 of them. That means it is a total of basically a -2 charge. So if this is a -2 charge total, because I have 2 of them, then I know for this to be neutral, I had to use the +2 of the iron. So when I name this, I am going to do iron and then those Roman numerals. 2, because that's the ion I'm using, and then name the ending. Well, that would be chlorine, but again, make sure you add or change it, I should say, to IDE from INE. Mg. Mg is only a +2, so I don't have to worry about it. So I just look it up, and it is magnesium. And then I name the other ion, which is oxygen. Well, oxygen becomes oxide. So it doesn't have that nice INE to know how to change it. You'll just get used to some of them as we go through. So it's like that last syllable kind of thing that you kind of drop off and change the ending to. And then we have Pb. Pb is lead, and Pb comes as +2 or +4. So again, we have to look at my anion. So I have sulfur as my anion, and if I look it up, it has a -2 charge. Well, I have no numbers down here, so I only have 1. So it's going to stay -2, so that means my lead is going to be +2. So again, I'm going to call it lead 2. Here's another one that's not an INE, but a UR, and we're going to drop it and call it sulfide. So let's look at naming acids, because they kind of follow along the same idea. The way you know you have an acid is it's always going to start with H, except maybe one of them, but most of the time acids will start with H. And it's the anion that is going to drive the acid's name. If it is binary, meaning it is just 2 letters, so hydrogen and another element, it's going to start hydro and it is going to end ic. So your anion, instead of now changing to ide, is going to change to ic. I know, lots of rules. If we have more than 2 elements, our anion is a polyatomic ion. Now we slowly or kind of introduced you to this in the last chapter. These are those structures that you drew that had the negative charge. So these are your polyatomic ions. They contain more than 1 element. So it is going to be named based on the polyatomic ion name. Now, if you flip your pink sheet over, you have a list of several polyatomic ions on the back. And you're going to know that they mostly end in ate or ite. If they end in ate, we're going to change the ending to ick, and if they end in ite, we change the ending to ous. So let's look at some of the acids. So you can see they all start with H, so we know they're most likely going to be acids. In the first one, we only have 2 elements, so I know I'm going to start with hydro. And then I'm going to look up what Cl is. Well, that's chlorine. So I'm going to change the ending to ick instead of ide. So this is going to be hydrochloric acid. So let's look at the next one. I have H, and then I have ClO3. So I don't have just one element, but I have 2. So I know I have a polyatomic ion. So if I look on my pink sheet, I look up ClO3, and I see that the name is chlorate. So it ends in ATE. So I am going to change the ending to IC. So this is going to be chloric acid. So I didn't put hydro in front of it this time because it's not just 2 elements. Since I have more than 2 elements, I drop that hydro part and I name it just based on the polyatomic ion. So polyatomic ion ended in ate, so I changed it to ick. So this would be chloric acid. Again, here's my H. Here's my CrO4. So again, I have 2 elements. Don't worry about why we have a 2 there right now. It's not going to play in yet. So again, I just want to look up CrO4, and that is on your polyatomic ion sheet, and that is chromate. Again, it ends in another 8, so this is going to be ick. So this becomes chromic acid. Then we have HNO2, again a single H, but 2 elements. So I look up NO2, and NO2 is nitrite. So now I'm ite. So this becomes OUS. So I get NITROUS, nitrous acid, instead of nitric acid. So remember, ates equal ick, and ites equal OUS. Next one, I have H and Br, just 2 elements, so I'm back to my hydro, and then Br is bromide, so we're going to change it to bromic acid. So 2 elements gets hydro, change the ending to ick. More than 2 elements, look up the polyatomic ion, and then change it to ick or us, depending on the ending of that polyatomic ion. So let's name some regular formulas that have polyatomic ions. We're going to name them the same way as we did our binary ionic compounds. We start with the cation, and then we name the anion. How do we know we have a formula with a polyatomic ion? That's because we have more than 2 elements. So if we look at the following, remember, first thing you're going to do is look up SN. So I look up SN. Well, SN comes +2 or +4. So that means I have to look at NO3. Again, I have 2 elements, so I know it's going to be a polyatomic ion. So I look at the back of my sheet, and I look up NO3. NO3 has a negative charge. I have 2 of them, so I know total I have a -2 charge. So that means I must have +2 for SN. So SN is tin 2, and then name your polyatomic ion. So NO3 is nitrate. Let's look at Mg. Mg does not have two charges, it's just positive 2. OH, we have to look up the name, that's hydroxide, so this is just magnesium hydroxide, because that's the name of the polyatomic ion. So when you use polyatomic ions, you don't change the ending of the name at all, you just leave it whatever it says on the sheet. When we look at the next one, there are lots of letters. Since there are more than just 3 letters, there's a good chance we have 2 polyatomic ions. So in this case we do. This NH4 is a polyatomic ion, and SO3 is a polyatomic ion. So if we look at the top, we have NH4, and that is ammonium. So it's still a cation, so we don't do anything. And then we look up SO3, and SO3 is sulfite. So this would be ammonium sulfite. Now let's look at Al. Al, again, is only a positive 3, and that is aluminum. So all I have to do is look up whatever CrO4 is, and that is chromate. So I just write the name of the polyatomic ion, aluminum chromate. Fe is iron, and I look up iron, and iron can be positive 2 or positive 3. So that means I have to look up the anion. Well, in this case, my anion is a polyatomic ion, so I need to find PO4, and PO4 has a negative 3 charge. And since I don't have anything out here, it's assumed I have only one of them. Because remember, that 4 is part of the whole ion. So I have a negative 3 charge, so that means to keep it neutral, I had to use the positive 3 iron ion. So this is going to be iron 3 phosphate. And the last one, we look up cobalt. Cobalt, again, can be positive 2 or positive 3, so I have to look up my anion. So NO3 is a negative charge, but again, I have 2 of them, so that means I have a negative 2 charge total. So I need the positive 2 charge of my cobalt, so this becomes cobalt 2 nitrate. So that's pretty fast explanation of how to name ionic compounds, and in class you'll have lots more to practice with, but if you get the general idea of how to name them, you always name the cation, the first one listed first, then name the anion, and we often will change the ending to "ide" unless it's a polyatomic ion. And how do we know we have polyatomic ions? Because we have more than 2 elements in that formula. So now we're going to change you to molecular compounds, and these are going to be named a little bit different. I'm not going to ask you to know the difference between the ionic and molecular compounds. I'm not going to have you have to look up electronegativities all the time to figure that out. I'm going to tell you whether you're an ionic or a molecular compound so that you will have an idea of how to name that compound. Difference between the ionic and molecular compounds is that molecular compounds are held together by covalent bonds instead of ionic bonds. And when we name these, we are going to use prefixes to tell us how many atoms we have. So it's going to be much easier than what we just did. Only thing you need to know are these prefixes. So if we have 1 element, we're going to use mono. 2 is going to be di, 3 tri, for tetra, so that's going to be the harder one to remember. But if you think of Tetris, the game, everything is 4 blocks. So 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So you need to kind of memorize these. They shouldn't be too hard. They should be ones that you're sort of familiar with already. So rules that go into naming molecular. The prefix that you just saw is used on the first element only if there is more than one. If we only have one of the first element, we don't use a prefix. Then we're going to name the second element, and we're always going to use a prefix on the second element. And again, just like Ionic, we are going to change the name or the ending of the name of the second element to "ide." So at least something's the same throughout. And then just as a rule of thumb, usually if your prefix ends with an A or an O, it is often dropped if the element name begins with a vowel. So let's practice. We have SiO2. So we only have one Si, so we don't need to worry about a prefix, and we're just going to name it. So Si is silicon. Then we have 2 O's. So 2 is di. So this is going to be di. Then it's oxygen, changing the ending to IDE. So dioxide. So silicon, dioxide. P, again, we only have one of them, so we're just going to name what P is. So phosphorus. Then we have 3, so 3 is tri. And then naming Cl, chloride. Again, changing the INE in chlorine to chloride. Si, we only have one of them, so again, we have silicon. 4 is tetra. Remember that Tetris? So tetra, fluoride instead of, again, fluorine. Ooh, now we have 2 on the first one. So we need to use a prefix. So this is going to be dinitrogen. Oops. Yeah, not changing the ending of the name at all for the first compound. And then we have oxygen. Well, we only have one of them, and we always use a prefix on the end, so this has to be monoxide. This is where we dropped the mono, and dropped the O in mono, and kept the O in oxide, though it looks like we dropped the O in oxide. I don't know, whichever way you want to look at it. But it keeps it from being dinitrogen monoxide, and we call it monoxide. S, again, there's only one, so we're just going to name it. So we have sulfur. 3 is trioxide. So a little bit easier, no need to check any charges. So ionic compounds, we check charges. Molecular compounds are all by prefixes. So in class, hopefully you'll get lots of practice, and the more practice you do with this, the easier it will become. Hope you have a good night and you get lots of rest.